Okay, now we're talking about just the properties of compounds that are made with either ionic bonds or covalent bonds. We just call those ionic and covalent compounds. So if elements are bonded ionically, we call them ionic compounds, or if they're bonded covalently, we call them covalent compounds. And the bond that forms between them actually has a lot to do with their behaviors, which is pretty cool. So let's talk about ionic properties first. So we know that just due to the way that these things bond, the electrons have been transferred from one atom to another, and those electrons, they're never coming home. They have been transferred for good, and that makes a very, very strong bond. They exist as crystalline solids, all right? And so I painstakingly put together this little diagram here. This is representing ions lined up in a crystal configuration. So maybe this might be like sodium chloride or something like that with alternating positive and negative ions. And you can see that they align themselves in very neat rows so that all of the positive ions are surrounded on all sides with the negative ions and vice versa. And that does not make molecules of sodium chloride. That makes formula units of sodium chloride. Things like sodium chloride and other ionic compounds, they have really extremely high melting temperatures, really hot. It's really impossible for us by just normal means to ever melt one of those compounds into a liquid. So very, very hot. They won't melt under any condition we can put them through. They dissociate in water, and I'm going to describe that using that same little diagram. But before I talk about that, dissociation is not the same as dissolving. When it dissociates in water, the solution that gets formed will conduct electricity, which is kind of cool. So let's take a look at what that looks like. So here's our crystal again, and let's pretend that we've dropped this crystal into a glass of water. So what happens when salt, let's call this sodium chloride, when salt dissociates, what that means is that the ions actually spread apart from each other, and the entire substance sort of breaks up. And so all of the ions are floating around separate from each other, okay? And if this was in water, then electricity could pass through this solution by sort of jumping from ion to ion, kind of like jumping across rocks in a river or something like that. And so this is called an electrolytic solution because it conducts electricity. And that's gonna be if any ionic compound dissociates. Dissociate means to separate, and that's, as you're gonna see, a little bit different than dissolving, okay? So that's dissociation of an ionic compound to conduct electricity in water. And then the last interesting-ish property of ionic compounds is that they are typically odorless. The bond between the ions is so strong that not much of that escapes to make it into our nostrils. So they generally don't have a smell. Okay. Now, in terms of covalent compounds, the electrons that form the bond, they are shared electrons, not transferred. Covalent compounds can exist as solids, liquids, or gases, which is pretty cool, unlike ionic compounds, right? And some of the solids actually can take on a crystalline structure, even though they are covalent compounds. Like sugar is a really good example of that. Sugar is made from, here's a molecule of sugar right here. And you can see that it's made from carbon, hydrogen, and oxygen, all non-metal elements covalently bonded together. But when you lump a bunch of these together, they kind of look like a crystal, sugar crystals. You've seen those. The solids have relatively low melting temperature, so most covalent compounds can be melted very, very easily. So in water, they may or may not dissolve. And you notice I've used the word dissolve here rather than dissociate. And if they do dissolve, then the solution won't conduct electricity because let's do a little demo of that. So here's our sugar molecules. And let's just say that we've got these all, these kind of clumped together into a lump of sugar. And let's say that we put this into a glass of water. Unlike our dissociating ions that all spread apart from each other like that, these do separate, but the actual molecule does not come apart. So we just have these individual molecules just floating around like this. And molecules, as you know, are not charged in the same way that our ions were. And so that uncharged particles in water don't allow for electric current to go through. So this is what dissolving it looks like. It's what covalent compounds do, most of them. Some covalent compounds will not dissolve. Things like waxes and oils and things like that will not dissolve. We'll talk more about that later. Oops, wrong page. And then I think one of the most interesting things about covalent compounds is that they can have a really strong odor, either bad or good, actually. So all things that smell really good, you're smelling covalent compounds. And sadly, all things that smell really bad, you're also smelling covalent compounds. So that is just a little overview on how ionic stuff differs from covalent compounds.